Welcome to this video on data science interview exercises, where we will take a deep dive into some of the most commonly asked questions and challenges that employers use to evaluate candidates in the field of data science. As data science continues to be one of the fastest growing and most in-demand professions, employers are seeking out top talent with the skills and knowledge to succeed in complex data-driven environments. So what we are going to do in this video is we will make a data science interview exercise. I prepared 5 interview questions and answers. I will firstly show you the 5 questions that we are going to be talking about in this video, and after that I will start giving them answers one by one. So let's see the questions. Here are our questions. I won't read them one by one here since I will be reading them before answering them. You can pause the video for seeing the questions and answering them. That was all for the introduction of the video. Thanks for watching by here. Let's give answers to these questions. What is cross-validation? Cross-validation is a common technique used in machine learning to evaluate the performance of a model and estimate its accuracy. The main goal of cross-validation is to test a model's ability to generalize to new data that was not used in training. In cross-validation, the dataset is split into a number of folds, typically between 5 to 10, with each fold containing a subset of data. The model is then trained on one subset and tested on another subset, and the process is repeated for each fold. The most common type of cross-validation is k-fold cross-validation, where the data is split into k subsets of equal size and the model is trained and validated k times, each time using a different fold as the validation set and the remaining k-1 folds as the training set. The performance of the model is then averaged over the k iterations to obtain a more accurate estimate of its accuracy. What's an outlier? In data pre-processing process, what are the ways of dealing with outliers? Outliers are data points that are significantly different from other observations in the dataset. Outliers can occur due to measurement errors, data entry errors, or nature variation in the data, and they can have a significant impact on the results of data analysis. Some ways to deal with outliers in data pre-processing are: identify and remove outliers. One common approach is to identify the outliers in the dataset and remove them from the analysis. This can be done using statistical methods such as the z-score, IQR method, or visualization techniques like box plots. Once identified, outliers can be removed from the dataset. However, removing outliers may also remove important information from the dataset. Winsorization. In this method, the outliers are replaced with the nearest non-outlier data point. This can be done by either setting the outliers to the nearest non-outlier or by limiting the range of the data to exclude the outliers. Transformation. Another approach is to transform the data, such as applying a logarithmic transformation, which can help reduce the impact of outliers in the dataset. Bin outliers. Another approach is to treat outliers as a separate category and create a new bin or group for them. This can help in some cases where the outliers represent a distinct behavior or phenomena. It's important to keep in mind that outlier handling should be done with care, as it can have an impact on results of the data analysis. The approach chosen for dealing with outliers should be based on the nature of the data, the goals of the analysis, and the specific characteristics of the outliers in dataset. What is p-value? P-value is a statistical measure that represents the probability of obtaining a result as extreme as or more extreme than the observed result, assuming that the null hypothesis is true. In statistical hypothesis testing, the null hypothesis is a statement that there is no significant difference between two groups or variables, while the alternative hypothesis is a statement that there is a significant difference between two groups or variables. The p-value helps to quantify the strength of evidence against the null hypothesis. If the p-value is small, typically less than 0.05, we reject the null hypothesis and conclude that there is significant evidence for a difference or effect between the groups or variables. If the p-value is large, we fail to reject the null hypothesis and conclude that there is no significant evidence for a difference or effect between the groups or variables. P-value is affected by the size of the sample, the magnitude of the effect, and the variability of the data. A small p-value indicates that the observed result is unlikely to occur by chance alone, while a large p-value indicates that the observed result is likely to occur by chance even if there is no significant difference between the groups or variables. It's important to note that the p-value doesn't indicate the size of the effect or the importance of the result. The p-value only provides a measure of the strength of evidence against the null hypothesis. Therefore, it should be interpreted in conjunction with other measures such as effect size, confidence intervals, and practical significance to make informed decisions based on statistical analysis. What is extract transform load? ETL is a process used in data warehousing and business intelligence that involves extracting data from various sources, transforming it into a consistent format, and then loading it into data warehouse or target system. The first step in the ETL process is to extract data from various sources such as databases, flat files, and web services. This data is then transformed to meet the requirements of the target system. The transformation step may involve cleaning and filtering data, converting data types, aggregating data, and performing other operations to ensure that the data is consistent and accurate. After the data has been transformed, it is loaded into the target system such as data warehouse or a business intelligence application. The data may be loaded in batches or in real time depending on the requirements of the system. ETL is an important process in data warehousing and business intelligence because it enables organizations to consolidate data from various sources into a single integrated view. This helps organizations to gain insights into their business and make informed decisions based on data. What is ensemble learning and how it can improve model performance? Ensemble learning is a machine learning technique in which multiple models are trained on the same dataset and their predictions are combined to produce a final prediction. The goal of ensemble learning is to improve the overall predictive accuracy of the model by combining the strengths of multiple models. In boosting, multiple models are trained sequentially, with each subsequent model learning to correct the mistakes of the previous model. This technique can be particularly effective for improving the accuracy of the model on difficult or complex datasets, as it can help the model to learn more complex relationships between the input features and the target variable. Overall, ensemble learning can improve model performance by reducing overfitting, improving the suitability of the model, and capturing more complex relationships in the data. However, it's important to note that ensemble learning requires more computational resources and can be more complex to implement than traditional machine learning models. Thank you for watching this video on data science interview exercises. I'm creating data science content. If you want to see more videos like this, you can subscribe to my channel. Have a great day.